Welcome to the session on efficiency. This is the second session on efficiency. In this session, we are going to look at some of the graphical methods of quantifying efficiency and comparing efficiency of economic units. The theoretical basis for even this graphical method is a technique called Data Envelopment Analysis, and we are going to look at this Data Envelopment Analysis, or DEA as it is called, in detail as we go forward. So let us look at simple graphical tools to understand efficiency of an economic unit and how do you compare a set of economic units. So if things are very simple, we had looked at operating ratios, we had looked at financial ratios earlier in the session, in the previous session. If we are in this utopian world where there is a single output and single input, then we will say, there is nothing, this is very trivial, a simple ratio of input to output will tell us what the efficiency is. Find out which economic unit has the highest ratio, and that economic unit will be the most efficient. All the other economic units, it's a ratio of output to input. The only way to increase this ratio is to either increase the numerator, which is the output, or reduce the denominator, which is the input. So either you spend less input to make the same output, that will fare you well, or with the same amount of input you produce more, right? You get more output. Those are the only two ways, right? So for this very trivial example where we have a single input and a single output, this is what a graph would look like, right? So let us say that various sales offices, they have a certain budget allocated to them, and based on the marketing budget that they are allocated, they need to generate some sales. So let us take this set of 5 sales offices. Their budgets are different, obviously, because of management decisions, and the sales that they are able to generate from that geographic location or from their business circle of influence is also quoted in INR. Right, so obviously sales is an output variable. Sales is an output variable, and the budget that they have invested is the input variable. This is a simplistic example of a single input and single output. So I would say, what is the efficiency? Just calculate, right? So what is this 3.7? 3.7 is essentially sales, which is output, divided by the budget. So sales office 1 has a ratio of 3.7, whereas sales office 5 has a ratio of 13. As we said earlier, the highest ratio is called the most efficient economic unit, and therefore in these calculations we would end up concluding that the sales office 5 is the best performing sales office, because the sales per rupee invested is actually 13, which is highest in the sample. Graphically it would look like this, right? So these budget, these are the budget values, which is the input. These are the sales values, which is the output, and essentially you draw a line, and the line with the highest slope, the line joining the origin and individual economic units, right? If you draw this line, it is going to look like this. If you draw this line, it is going to look like this. So by ratio, we essentially mean the slope, and the line with the highest slope, that particular economic unit is going to be considered the most efficient. Makes sense, right? Simple enough, very simple. Single input, single output. Single input was budget, single output was sales, and simple calculation of ratio of sales divided by budget. Unfortunately, as we have discussed earlier, things are not this easy. Things are generally complicated, right? Most of the times we have more inputs and more outputs. Sometimes we have more inputs, sometimes we have more outputs. Most often we have more inputs and more outputs. So let us increase the complexity step by step. Now let us take an example where we have 2 inputs and a single output. Right? Earlier we had single input, single output. Now increase the input. Now we have 2 inputs and a single output. We will take this sales office as our benchmark example. So all the scenarios are going to be described in the context of this sales office, right? Let us increase the number of inputs that goes in the calculations, right? And we will keep the output single output, right? So let us take the same example, but now let us fix that every sales office has a sales target of 10 lakhs. So we have kept the output as sales, same as last example, but now we are fixing the output for all the 5 sales offices. So this is obviously the output. This is obviously the output, right? But this is fixed for each economic unit. Now, what are the 2 inputs that we are going to consider in this example? Let us continue to consider budget as an input, right? So they have their individual budgets that are approved by the management, and they have a marketing team available in that particular office, right? Sales team or marketing team. I'm generalizing this, of course. I'm using the sales team and marketing team interchangeably, but we do understand that if you are really trying to achieve sales targets, you would need a very strong, very aggressive sales team, and definitely very effective marketing efforts also, right? But let us now not worry about the differentiation between whether it is a sales team or marketing team. Let us say that there is some team and the number of people in that team, right? So obviously if you have more workforce available in your sales team, you are able to aggressively target your customers and therefore hopefully reach the sales target fairly easily. If you have higher budgets available, if you have lots of money to spend, probably you will go aggressive on advertising, you will go aggressive on customer acquisition, and therefore hopefully increase or reach your sales targets fairly easily, right? Always true, right? The more inputs that you can invest, you are hoping that the output is very easily achieved. Efficiency, however, is a different ball game, where we are trying to say, well, how do I achieve this sales target with minimum amount of budget and very minimal workforce available with me, right? That's going to be the question. But let us understand the data for this example. So we already have the data for the output, and that data is this 10 lakhs, right? That is the output. What is the input data? Budget and team sizes. These are the values available. So every sales office has budgets, and if you notice, the budget values I have not even changed. Budget values are same that we had used in the previous example. The team size is the new data that is now made available to us. That is the additional input that we are going to consider in this example. Now, in the earlier graphical output, we plotted output on the y-axis and input on the x-axis, right? Remember this? Yeah. So budget was the input variable which was plotted on the x-axis, and sales was the output variable which was plotted on the y-axis. We actually, in this example of 2 inputs and 1 output, we actually don't have to plot the output, because output is same for all the 5 economic units. Output is 10 lakhs. Every sales office has to meet this sales target. If you do more, that's okay, but you have to hit this magic number of 10 lakhs. So we are not even going to plot output, because output is same for all the sales offices. We are only going to plot the inputs, budget and team sizes. So let us plot that and look at how the plot looks like. So once again, budget, which is our input variable, is on the x-axis, and team size, which is also an input, it is on the y-axis. And all the points are plotted. This is point number 1, 2, 3, 4 and 5. These are the 5 sales offices. Now, how do you look at efficiency? Which economic units or which of the sales offices would you call efficient sales offices? Obviously, we are plotting only inputs, so lesser the better. So those economic units which consume less resources, less inputs, therefore smaller team size, smaller budgets, or both, they will in general come out as efficient units. Where do you see that? Can you make a guess which of these 5 units may turn out to be quote unquote efficient, and I have not told you the exact expression for efficiency. So right now what you are doing is only a guess. Okay, so essentially look at this 2, right? 2 is lesser in terms of budget, smaller team size, so 2 is definitely going to be efficient. So I can tell you that if you do this, right, so these 3, 5, 2 and 3 are going to be called efficient sales offices because they consume less resources. 5 is efficient because it consumes very less budget. 3 is efficient because it has the smallest team size. Relatively speaking, 2 is efficient because it is lesser on both, so to say. 1 and 4 in general are not going to be called efficient units because, as we had discussed earlier, they are not on efficiency frontier. They are not on efficiency envelope. Right, so this is going to be the efficiency frontier for our example where we have 2 inputs and 1 output. The envelope is going to be on the left hand side because we are only mapping the resources. So lesser resources the better, and therefore that's how the efficiency frontier is going to be drawn. The question to ask is, well, how did you suddenly decide 5, 2 and 3 are going to be efficient? Well, hold on. As we said, this came out of an analysis called DEA, Data Envelopment Analysis. Right, so this is the graphical output of Data Envelopment Analysis. We are slowly building our concepts so that quickly we will look at the mathematics also. So since this was essentially input mapping, we drew the frontier on the lower side, which means lower inputs, better the economic output. Right. Let us go the other way. Let us look at the example where we have a single input, keep the input constant and single, but let us have 2 outputs. Exactly opposite of the previous example. Right. We will continue with our benchmark case of sales offices and comparing sales offices. So now let us say that every sales office has been given the same budget. 2 lakhs is the budget given to all of them. Let us not worry about the team sizes, right? Let us not worry about the team sizes. So let us keep input as single, which is the budget, and keep it same for all the sales offices, which is 2 lakhs. Now look at 2 outputs. One output that we have always been tracking is the sales in rupee value. But let us also consider one more very generic, very commonly used output, which is potential leads, right? So these are the potential customers whom we have targeted, whom we have approached, and they definitely look promising. They might end up buying. Now you can say that my entire market size is my potential customers. Yes, but that is different from actual leads, right? So out of this entire market of customers who may buy your product, there are certain customers whom you have repeatedly met, you have built up the rapport, you have explained to them why your product is better, and they seem to be convinced, even though they have not made the purchase decisions yet, but they are more inclined than others to buy the product. So that's what we call them as leads, and they are outputs, right? Essentially they are not inputs. You have spent money, you have asked your teams to contact these target customers, and they are your potential leads, right? So you have invested money, you have invested people's time, right? And therefore they are outputs. So as we had done earlier, we will not look at the input variable because input variable is single, which is budget, and input variable is constant for all the sales offices. Let's not worry about it. Let's look at the data for sales achieved and the potential leads that we have obtained in this particular time period. So this is the data, right? This is the data. So this time I have kept the budget constant, which is 2 lakhs, therefore not even included in the table, and hopefully I have kept the sales values same as the first example of single input, single output, right? This is new data. This is new data, which are the potential leads that we have from our sales and marketing efforts. Now what we are going to plot is only the outputs. We have two outputs. We are only going to plot the outputs and not worry about the input, because input is same for all the sales offices. Input is budget and it is 2 lakhs. Let us plot the output, and the output is going to look like this. So here we are plotting only the output. So sales is an output which is on the x-axis, number of leads are the output which is on the y-axis. We could have flipped it and drawn it the other way also. Number of leads could have gone on x-axis, doesn't matter. The idea is always remember that we are only plotting the output. Now how would the efficiency frontier look like? Now it is output mapping. Output mapping means more the better. More sales, yes. More leads, yes. With the same budget, are you able to reach higher sales values? With the same budget, are you able to convert any customer into a potential lead? Right? That's the question we are asking. So in general, 1 and 2 are not that great because they are not performing too well on sales, not performing too well on the leads, and therefore 4, 5 and 3 are going to be on what is called as the efficiency frontier. And you can draw the horizontal line here, you can draw a vertical line here to close the envelope. Right? Why do you draw this horizontal line? Why do you draw this vertical line? Why is it vertical? Why is it not going this way? All that is essentially the technicalities of data envelopment analysis. But essentially the frontier, I have drawn it slightly bad. Let us do this properly. So this is how the efficiency frontier going to look like for a 2 output single input scenario. Output is on the outer side because we are talking about the frontier is on the outer side because we are talking about outputs, right? More output, better, right? So in the earlier example, we had frontier drawn on the lower side. Now we are drawing frontier on the upper side, right? Covering the outer covering, right? So this is called the envelope, efficiency envelope, or this is called the efficiency frontier. I hope I'm being clear. You have to understand that all these graphs were possible because we kept it at 2 dimensions, right? 3-dimensional plots are slightly difficult to imagine. 4 dimension onwards, we can't even imagine. So wanted to explain the ideas with simple examples and therefore took 2-dimensional plots, but it conveys the idea. Conveys the idea that we are going to look at efficient DMUs, efficient economic units. Efficient economic units, those efficient economic units are going to sit on the frontier. Those economic units are going to sit on what is called as envelope. In this case, it was 3, 4, 5. In the previous case, it was 2, 3 and 5. So those are the efficient economic units. 1 and 4 here, and 1 and 2 here are not so efficient units. And how did we decide that 3, 4, 5 here will get highest efficiency? That's what we will discuss next. Essentially, we have looked at it graphically. Next thing, we are going to look at this analytically. But remember, graphical method helps us in these simple scenarios. Graphical method may not help us in more realistic scenarios where we have several inputs and several outputs, right? Difficult to imagine higher dimensional graphs, and imagine this frontier which is not going to be a line but it is going to be a polytope, right? So in 3 dimension it is going to be a plane. In 4 dimension it is going to be even higher order polytope, right? So difficult to imagine those. Therefore, graphical method helps, but graphical method helps only in simple scenarios. Hope these ideas were clear to you. We have moved 1 step closer to quantifying the efficiency and quantifying the efficient economic units. Let us proceed further on the analytical method in the next session.